Welcome to another Mathnificent conversation. This video is a continuation of our featured guest adding and subtracting fractions. In this video, we're going to focus on subtracting fractions. So grab your pencils and let's go. Subtraction essentially follows the same rules as addition because subtraction is defined as addition. So subtraction is the same thing as addition of the opposite. So because every subtraction problem can be written as an addition problem, it follows the same rules. So if we're subtracting two things, the same thing occurs. They still have to be like terms. We're still talking about fractions. So like term means the same denominator. So here we're starting and we have 3/4, which means we have something split into 4 equal parts and we have 3 of them. And then we're taking away something split into 4 equal parts and we have 2 of them. So this is visually what 3/4 minus 2/4 looks like. So how I'm going to display that is I'm going to say from my 3/4, take away 2 of those fourths. And that's going to leave me with one second here. Only 1/4. So we see we still follow our same rule. We subtract the numerators. 3 minus 2 is 1. And we keep the denominator the same. So 3/4 minus 2/4 is equivalent to 1/4. And that's already in its simplest form. So we're finished. Now we're going to look at 5/8 minus 3/8. So remember, 5/8 means we have something split into 8 equal groups, and we have 5 of them. And 3/8 means we have something split into 8 equal groups, and we have 3 of them. So I have 5/8, but I want to take away 3/8. So that means from my 5/8, I'm going to take away 3 of those eighths, and that's going to leave me with 2/8. So again, we subtract the numerators. 5 minus 3 is 2. Leave the denominator the same. If we start with eighths, we have to end in eighths. So 5/8 minus 3/8 is 2/8. Now 2 and 8 are both even. We don't leave our fractions unsimplified. So I'm going to do the prime factorization of 8. 8 is 2 times 2 times 2. A number divided by itself is 1. So that 2/2 simplifies. And we're left with 1/4. Okay, our next example, we have 12/7 minus 5/7. Now 12/7 should start to jog our memory. My numerator is bigger than my denominator, which means I've created a whole of sevenths with some left over. So visually, 12/7 is 7 out of 7, and then another 5 out of 7. And you can see that with our blocks. And then we're going to take away 5/7. So if I start with 12/7 over here and I take away, I'm going to start from the end. 1, 2, 3, 4, 5. That's taken away all of my extra pieces and left me with 7 out of 7. Okay. 1, 2, 3, 4. 7 out of 7 is left, but a number divided by itself is 1, which we should have been able to see. We're left with 1 whole after we take away the 5 sevenths. Okay, our last example, just to make sure you have a swing of things. 7/9 minus 4/9, we already know we subtract the numerators. 7 minus 4 is 3. Leave the denominator the same. So we should get 3 out of 9. I'm starting with my 7/9, and from the end, I'm going to take away 4 of those ninths. And that leaves me with 3 out of 9. 3 out of 9 is not simplified because 9 can be rewritten as 3 times 3. And I have a 3 in the numerator and a 3 in the denominator. That's simplified to 1. So I'm left with 1 out of 3. So as a recap, when we're adding or subtracting fractions with the same denominator, I'm going to put A over C plus or minus B over C. We add or subtract whatever is in the numerator. We keep the denominator the same. There's not much more to it. When you're adding and subtracting fractions, as long as they are like terms, you either add the numerators because that's how many of those parts we have, or you subtract the numerators because the numerator tells us how many of the parts we have, and the denominator is telling us what the equal parts are. I hope this was helpful. This is a long series. We're going to do adding and subtracting rational expressions next so that you see how the numbers translate to the expressions. Remember, you are magnificent. You're brilliant. I'll see you in the next video.